Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Hadri. I'm from Group E. I will explain you about the instruction set MULs. MULs is an instruction set used multiplication to multiply the instruction. MULs use 32-bit operand and produce 32-bit result. The program is such as here mass, RD, RN, and RM, which is RD will be the destination, RN and RM will be the register that holding the value to be multiplied. Okay, in the multiple instruction set, multiplication instruction set, the restriction is the RD, RN, and RM must only specify between R0 to R7 only. The other restriction is the RD must be same as RM. For the multiplication, the flag will be updated on N and Z only, but not affected to the C and V. Okay, the example of the multiplication instruction sets, such above, such in the screen, mults R0, R1, and R0. This is the correct multiplication instruction set because the RD and RM is the same. So for the second example, this is an error because RD and RM are not the same, which is R0 and R2. So for the third example, also an error because the register hole is R8. The restriction is only a restriction told that is only R0 to R7. Okay, below is the manual calculation for the register that hold value 11111111 and 2222222. This is a manual calculation. Okay, on the microvision example, for the left picture, it shows as a 0 error, and for the right there is a 1 error because the R1 for the RD and RM are not the same. For the RD is R1 and RM is R0. Okay. On the left is the result for the register of multiplication. The right picture is the result on the microvision. So we load the R0, we load R1, we load R2, and then we'll multiply R1 and multiple R2 and R1 and be stored into the R1. So on this red circle, this is the result, which is the same as the manual calculation. Microvision error, which is from the picture we can see here on the below there's two errors. One is because of the load errors because LDR only hold a value from R0 to R7. Also for the multiples error because there is a R8 in the program. The restriction say that multiples can only hold from R0 and R0 to R7 only. So this can cause error to the program.
Assalamualaikum warahmatullahi wabarakatuh. I am Alwani binti Aziz from Group E. I will explain about the compare instruction. There are two syntax of compare instruction. First, compare Rn, which is the register holding the first operand with immediate value. Then, another syntax is compare Rn with another register which is RM. Next, the operation of compare instruction. This instruction compare the value in a register with either the value in another register or the immediate value. The compare instruction will update the condition flag on the result but do not write the result to a register. The compare instruction subtract either the value in the register specified by RM or the immediate from the value in Rn and update the flag. This is the same as sub instruction except that the result is discarded. Next, for compare instruction, the value of Rn and Rm can specify from R0 to R14. Then the immediate value must be in the range of 0 to 255. The compare instruction will update the N, Z, C and V flag according to the result.
Okay, we proceed with the simulation. First, build the file and zero error, run the debug. Load 8765 to the R1, load 4321 to the R2, and then compare R1 and R2. It will update at PSR, which is and ZCB. Carry will be 1. Later I will show you why carry become 1. Okay, we go to the manual calculation. R1 000 8765 and R2 0000 4321. Okay, the carry become 1 because from manual, the carry occurs when the result of subtraction is positive or 0. Okay, we see the first, which is this is the positive, and the carry will be 1. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Ali Sulaiman bin Muhammad Johari. I'm from FKEE, Faculty of Electrical and Engineering. Today I want to present about assignment from a subject BEE 2223 microprocessor. This is a group task. Okay, I'm from Group E, and Group E will present about MUL CMP CMN. I will to talk about the CMN instruction. I will explain it some explanation and the example. Okay, let's go to the CMN. Okay, CMN is the instruction. It adds the value of the Rm to the value of the Rn and update the flags. Flag is this. N, Z, C, B. N is the negative, Z is the 0, C is the carry, and B is the overflow. This is the same as an add instruction. We go to in later, except the result will be discarded. Meaning is discard will not be shown, will not be appear as a result. Okay, RM, let's see what is the RM and Rn. CMS, Rn and Rn. Rm is the register to compare with, whereas the Rm is the register to holding the first operand. This is Rn, this is Rm. The value of the Rm to the value is Rn. The Rn plus with the Rn will plus with Rn. Okay. Is that is the same as the add instruction. Let's go to the add instruction. The add instruction is to perform the same operation as in add, and also the update N, Z, and C and the reflex. And add instruction as the value in the Rn to the value in the Rm with addition to the Rn or an intermediate value. This is intermediate value. Specified by IRM and place the result in the register specified by RD. Okay. Let's see the here. Okay, this is an example of the template of micro PCMN. We use a data 4321 and for the R3 and 7654 for the R4. This is the data in the binary. Okay, we add R3 and R4 because CMN is same as add instruction, but it will not show the result. Okay, let's add the data. 1 plus 0 is 1, 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 0 is 0. Okay, this is the answer for this one. 0 plus 1 is 1, 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0. Okay, for this one, 1 plus 0 is 1, 1 plus 1 is 1, 0, 0 here and 1 go up here. It's carry. 1 plus 0, 1, 1 plus 1, 1, 0. 1 will go up here. 1 plus 0, 1, 1 plus 0, 1, 1 will go here. Okay, for this one, 0 plus 1, 1, 0 plus 1 is 1. 1 plus 1 is 0, 1, 0, 1 go up here. 1 plus 0, 1, 1 plus 0 is 1. It will show as B 9, 7, 5 in the hexa value. When we convert this to we will convert this to the hexa value, we will got this. Okay, the update flag is N negative is 0, Z is 0, carry is 0, B is 0. Okay, let's go to the solution. Okay, this is my my coding. Let's go. We'll see if the coding is error or not. This is no error and 0 warning, which is perfect. Let's go to the debug. Okay. Okay, for this one, I will go jump into here because I will explain about CMN way. For CMP, the other my member group will explain. Okay, let's go jump into here. Sorry. Okay, the R3 which is data 4321 will store in the R3. Okay, the execute 1, 2, 3. We need data LDR which is store data in R3 4321 is shown here. For the R4 7654 will store in the R4. Yeah. For the CMN will go the data. Here is carry is 1. But when we execute, we will see the result 1, 2, 3, and it changes to 0, which is the if update flag. For the X, R3 and R4, you will see it will have this answer. Let's execute 1, 2, 3. We will show the result in the R3. in R3 now is 43 to 1. It will change 1, 2, 3. This now 000 B975, which is same as the B975. Okay, I will explain why this is all 0. Okay, negative is 0 because this is positive, not no number is negative. 0, it's only not 0. There is 1 here, 1 here, 1 here. Here the C is carry is 0. Why is it 0? Because the result of an addition is greater or equal to the 2 power of 32. But in here we got not more than 2 power of 32 for the overflow. For overflow, the R3 of the value of this R3 and the R4 must be either this is plus or this is minus, this is negative, this is positive. But in here, this both of them is positive, and it will appear 0.
Okay, Assalamualaikum warahmatullahi wabarakatuh. First of all, I want to thank to my partner Alif for passing the baton to me to continue our presentation. So as for my introduction, my name is Muhammad Iman Syafiq bin Muhammad Nasir. You can call me Aiman, and for my ID number is EC17029. So for today, I am going to present about what is CMN is all about and its restriction. Okay, let's jump into my presentation right now. So what in the world is CMN? Okay, CMN is instruction for add. CMN is a short form for compare negative, which permits you to compare two values. This instruction adds the value of Rn to the value in Rm and update the flags. Don't misunderstood with CMP. CMP and CMN is a one completely different instruction, which is CMP is a compare positive that subtracts. Okay, remember that CMN adds, CMP subtracts. Subtract the value operand 2 from operand 1. So in general, CMN instruction is for comparing the values registered against small negative numbers. So that's all for the CMN introduction. As for the restriction, okay, so for the restriction is the thing you should not do if you want to use CMN in your kill to prevent from getting errors all the time. Okay, so fortunately for the CMN, there is only one restriction that you have to follow, which is the instruction of Rn. The Rn is the first R, and the Rm, which is the second R, must only specify from R0 to R7 only, which means, as an example, we can use CMN R0, R2, or you can also use CMN R3, R5, as long as the Rn and the Rm is in the range of R0 to R7. And you must never ever use lesser or bigger than the range of R0 to R7, such as CMN R-3, R15. Or you shouldn't also use CMN R-5, R20, no. As long as the Rn and the Rm is in the range of R0 and R7, we can eliminate the error. So this is an example that if you didn't follow the restriction rule, which you can see here, there are 4 errors that were found by the kill itself from the line 100 to line 103. So the kill itself told that if you want to register the Rn must be from the range R0 to R7 only. So that's why this example is wrong, which I use the Rn outside from the R0 to R7 range, which is I use R8, R8, R9. So always remember the restriction when using CMN in your coding. Never put your Rn outside the range of R0 to R7. So for the next example is the correct example, which is we can see that there is no error that we found, because to eliminate the error from the current example, we just have to change the Rn and the Rm follow the range R0 to R7, which I use here, R3 and R4. That's why this example is successfully. So that's all for me, sir. Thank you for lending us your eyes and ears for our presentation. We wish you have a great day. Thank you.